Hello and welcome to Sudoku. Here is a Mathrax Sudoku that was created by MadMahogany for the Sudoku Mahabharat, a round dedicated to math variants. So what is the principle of Mathrax Sudoku? Well, math, or more precisely, this means that both diagonals have a product of 12. This means that both diagonals have a difference of 1. Well, same for the other operations. This O means that all 4 digits are odd. This E means that all 4 digits are even. So let's start. And I must say that when I took part in this contest, I performed very badly because I kept breaking all puzzles, and I broke this one. So that doesn't mean the puzzle is not good. It's actually very good. Right. So the first part will be to notice that those parities will spread to the rest of the grid through all the clues. So I just write down the parities of every single cell. So from the beginning, we already have the parity of some numbers, given or not. And, well, that seems a bit useless to write parity where it's already written, but it allows me to have a better sight of what has to be done, a better view. For example, I see 4 even digits now. I know that all remaining digits in the rows must be odd. That's the first thing. Here we have 5 odd digits, so the remaining ones must be even. Next, here we have 5 odd digits, so the remaining digits must be even. And for those 2 digits, we could have deduced that from this difference of 1. And here, a difference of 3 switches the parities, and a sum of 10 preserves parity. What's next? This division gives a result of 2, so there must be an even number divided by something, so those must be even. Next we have 5 odd numbers here, so the remaining ones must be even. And now we have 4 even digits, so the remaining ones must be odd. And this one had to be odd because of this even digit and a sum of 7. And here that's an odd digit too. And something interesting with 9 is that whenever you have a sum that is odd, one of the digits has to be odd and the other one has to be even. So there is an even digit on each diagonal that makes 4 even digits, and those ones now must be odd. And actually, I could have used the fact that all those we already have 4 even digits here, so those ones are odd and those ones are even. Is that correct? It is correct. On this column, I have 4 even digits, so this one is odd. On this one, I have 4 even digits, so those ones are odd, and this one is even. Here, is there anything? There's something about the 12. The possible products are 2 times 6 and 3 times 4. So I know there are 3 even digits here and 1 odd. And I can even be more precise with this. 2 has to be here or there, If 2 is here, that's with the 6, and we get 4 and 3 this way. Or 2 can be here, with 6 here, 4 there, and 3 here. Okay, so I still need 8 somewhere here, and an odd digit, and the 4th even digit has to be here. That's 4 even digits on this row, so the other ones are odd. Here, this one is even. Here we get one of each. Oh, but those ones are even. And this one has to be even. So those are odd. This one is even. This one is odd. And there's still something to be found here. But you see that we get an almost full repartition, is that a word? An almost full layout of even and odd digits. Okay. So where should I look? This result of 2 can only be 6 divided by 3 or 2 divided by 1. So we get a 1-3 pair here together with 6 and 2. And I wrote them correspondingly. So now the remaining even digits here must be 4 and 8, and because of this 4, I get an 8 here and a 4 there. This is 2 or 6. And 2, 6, 8 in some order here. 7. Those must be 2, 4, or 6. But, oh, yes, there's a 2 here, so what? No, this one is not 2. This must be 4 or 6. And this one is not 2 because it would put a 5 here, so it is also 4 or 6. And now those must be 2 and 8, and because of this 2, this is an 8, that's a 2. And because of this 1-3 pair, this is not a 3, it's a 2. And we get all those 4 digits. Those ones now must be 6 and 8. 2 is not here, it's there. That's a 4. This one can't be a 3, so it's a 1. Oh, finally an odd digit. And then what else can be done with even digits? There must be an 8 here. This is 7 or 9. Has to be a 5 out there. Okay. Now this is 6 or 8. Together with 4 or 2. This is 4 or 8. Oh, actually, oh yes, this one, 8 goes there, and 4. Actually, there had to be an even digit here. I didn't notice. So 8 is here, that's a 4, and it resolves all of this. This one is a 1, this one is a 3, that's it. This one is a 6. We get a 4-8 pair here. And let's not forget that the sum is 9 here. What do we know about those? Not sure. Is there anything else? Oh, yes, this one goes there. This is 7 or 9. Oh, this one is 8. And we get 6 or 2 here. That's a pair. So this one is 8. This one is 2 or 4. 8 or 6. Yes, that's it. So now those 8 will go with a 5 and 6 with 3 or 9. This one is not a 4. This one is not an 8. Oh, here we get an 8 on this row. So this one is a 4, this one is an 8, this one is a 1. 2 and 6 here. This is 2, 4 or 6. I know nothing about this, so that's not very useful. Where else should I look? Here I still need 5, 7 and 9. Oh, or perhaps here. This is not 1, this is not 3. It can't be 5 because it would repeat the 5, so it must be 7 or 9. Or is there a way to find the remaining even digits? Oh yes, on this row 8 can only be here. So this one is 8, that's 6, that's 4, 8 and 6 here. That's 2, that's 6. I still need 2 and 4, and because of this, that's a 2, that's a 4, that's a 6, that's a 2, and I think I get all of them. No, there's still this that needs to be disambiguated, and this will come in due course, I guess, with the rest. So this is with 3 or 1. And then what? Arithmetics. This 2 makes this a 7. Now I get this 9 and this 1. That's not a 9. Okay, this 5, this 3, 5 pair disambiguates that. That's a 1, that's a 3. This one is a 2. This is a 7. Now I get this 9, this 7, and this 9. This one is a 3. It's easy to get lost in this sea of O's and E's. This one is 7 or 9, and I still don't know which one of them. 5 and 9 here, there's a 5. I often get to overlook the given digits. This one now goes up there. This is a 5. 7 and 9, there's a 7. No, no, no. What did I do wrong? This is a 5. Well, yes, I say the 5, and I wrote a 7. That's typical Sudoku. Now this has to be a 3. 5 and 7. There's a 7 here. 3 and 5, there's a 3. This one is a 3, that's a 9. And now this is all plain Sudoku. I just need to be careful and not put wrong digits. But I don't think I need to explain the process in a full, well, I don't need to give full explanations. That's a 7, 7, 5, 9 here and 1 there. I think this is correct. Okay, so this was a bit tricky, especially if you don't think of going for odd even stuff right from the get-go, but you can get the idea from the fact that a lot of parities have been given already, and really the fact that all those operations help to spread parity. Thanks for watching this video. See you soon on Sudoku.